Hi guys, let's solve this problem as I read the question first. Evaluate the triple integral. You have here integral from 0 to pi over 2, then integral from 0 to 4 cos z, integral from 0 to square root of 16 minus y squared. You have 3y dx dy dz. So the first thing guys we are going to establish is that we are going to differentiate first this, that is with respect to x. We also at the same time, after we integrate with respect to y, and then lastly we integrate with respect to z. So guys, let's see what happens. So this is what we are going to do guys. We are going to integrate first this loop, that is loop 1. We integrate then the second loop, and the third loop which is with respect to z. So guys, we start off. So we are integrating the first, that is with respect to x. So guys, we have from 0 to square root of 16 minus y squared. If we integrate that, guys, this is a constant as of now because we are integrating with respect to x. So this one is considered as constant, and so therefore our solution is going to be this. Guys, we come and now replace for the limits. Replace with the 0, this becomes 0. Replace that, we are going to have 3y, and then you can put that. And this is what we have already done here. After I have replaced, guys, I can now do the second differentiation. Sorry, the second integration. That is from 0 here, from 0 to 4 cos z. And this is what guys now I'm going to do. Guys, when I integrate that, I will now consider my variable as y. And from there guys, I can say now let u, I can use u substitution, whereby guys I will say let u be equals to 16 minus y squared, and so therefore du is equals to that. And so we can replace the dy with du all over 2 negative 2y equals to dy. So instead of putting this, guys, we put this. And this is what we now do here. So guys, we have this, where already we have put the du all over minus 2y. Guys, we have now what we have substituted with, that is u, but guys, we have this as square root here, and that's why I've put there. So guys, we find that this y is going to cancel. Guys, now we come and integrate negative 3 over 2 and then u raised to a half. Guys, we integrate that, and this is going to give us u raised to 3 over 2. U raised to 3 over 2 all over 3, which is this, and then we have also another 2 here. So guys, these are going to cancel, that and that. And so we are left with minus u raised to 3 over 2 as our solution of integration. And then guys, we come and replace, as you know, u is the same as that. So guys, we can, instead of putting u, we put 16 minus y squared. And we come and replace for our y. And that's what we are going to do here. You can see guys, we have already, first of all, we put the negative aside. We shall use it later. So we have 16 minus, instead of putting y squared here, we put 4 cos z, that is 16 cos squared z. All that is raised to 3 over 2, now minus 16 minus now 0. This is our lower limit, and then we put 3 all over 2. Because remember guys, this, we have the upper limit for this and we have the lower limit for this. So guys, manipulating that, we are going to have this. This we can now multiply, we can now factor out the 16th, so it will be 16 raised to 3 over 2. We are left with 1 minus cos squared z raised to 3 over 2 minus 16 raised to 3 over 2. 16 raised to 3 over 2, guys, will give us 64. And this is what we have. So, guys, we have the 64 here. And we also have another 64 here. And, guys, we also have a negative here. So, from there, guys, we can multiply this negative with that negative. We get 64. Now minus 64 sine squared z raised to 3 over 2. That's what I have done there. Here, guys. Guys, after we have done this, I now go to the third integration. And this is the third integration now. Our limit is 0 to pi over 2, as it is written right here. This is from 0 to pi over 2. And so, guys, after that, now we come and integrate that. Guys, we can substitute sine cubed z by this equation. This is sine squared z and this is sine z, giving us sine cubed z. And so therefore, sine cubed z is equals to that. So guys, we can replace that for sine cubed z, as you can see here below. I have replaced the sine cubed z with that. Now I can multiply that, and so therefore I'll get something like this. Guys, this is now can be integrated very easily. Guys, when we come at this point, for this point is easy because here you just get 64z. This one you get 64 plus 64 cos z. But for this one, we can replace u with cos z. And so therefore du will be equal to minus sine z dz. And so therefore the dz is going to be du all over negative sine z. Guys, now we come and replace for that for the dz right here. And this is what, guys, we have done. We are concentrating on this side because this one is actually easy. So we have 64. Then we have du all over negative sine z and sine z here. So guys, I can cancel that sine z. So we are left with negative 64 u cubed all over 3. Guys, now I can now come and already I have integrated. Guys, as you can see, because u raised to 2, if you integrate, is 2 plus 1 all over 3. So this is already integrated, guys. We now come and replace for u, which is now cos z. So guys, we now replace our limits from 0 to pi over 2. And doing that, this is what we find, guys. Pi over 2 here, pi over 2, minus here we put also pi over 2. And this is what we have done for the first one. Guys, as you know, cos 90 is 0. So this one becomes now 0. And this also becomes 0. Now for the lower limit, guys, this is what we have. For the lower limit, we have 0 plus 64, which now becomes 0. And guys, we are now left with this one, because remember, cos 0 is 1. And so therefore, guys, we combine those, and this is what we are going to have. We are going to have that equation where we factor out the 64, because you can see all these have 64. This is 64, we have 64 here. And remember, guys, we have this, we have included also this 64z plus 64 cos z. And this is what we have included. Is actually here, guys, repeating myself. And so therefore here, guys, we come to 64 pi over 2 minus 64 plus 64 all over 3. Factoring out 64, we are left with that. And finally, this is what we have. And this is our answer, guys. So thank you for listening to me. Bye bye.